We're going to talk about a huge fundamental problem that sits right at the heart of science itself, the fact that most published research is basically a black box. But we're also going to look at a pretty brilliant idea that might just be the key to unlocking it.
So let me ask you this question directly. Think about any big scientific breakthrough you've heard about. You see the headlines, you see the cool charts, but could another scientist actually go in and check the work? Could they build on it? Well, the shocking answer is usually not. And the reason for that is actually pretty straightforward. It all comes down to this: the data. The raw, foundational stuff the entire study is built on, it's almost never there. So we get the conclusions, but the evidence that got them there is locked away. And that, right there, is a massive problem for trust and reproducibility in science.
So let's unpack that a little. We're going to dig into exactly why science has this giant lock on it and why getting to that crucial data is so incredibly difficult.
You know, it's not just one thing. There are some really good reasons. In medical research, for instance, you've got patient privacy, and you absolutely can't mess with that. In the corporate world, data is a trade secret. Sometimes it's just ridiculously expensive to store and share these gigantic datasets. And honestly, a lot of the time, the data is just gone, lost on some old laptop in a closet. This is a nightmare for everyone.
Okay, so when you're facing a problem that big, you can't just tweak around the edges. You need a totally new way of thinking. DBBUN is a research-driven effort. It was founded by Dr. Eric Horvitz with one specific goal: to solve this reproducibility crisis from the inside, from within the scientific community itself. This whole thing was born directly from feeling the pain of this problem firsthand.
Dr. Cartoon's work has been forged in some of the most elite research environments you can think of. We're talking MIT, Harvard, Massachusetts General Hospital, the Broad Institute, and IBM Research. So the solution we're about to talk about, it comes straight from the front lines of world-class science.
So how in the world do you share data that by its very nature you can't share? It sounds like a paradox, right? It's a concept that is, well, basically data without the actual data. The technology is called a synthetic data framework. And the best way to think about it is like a digital stunt double for the original secret data set. Now here's the magic trick. The system never ever sees the private data. Instead, it just reads the public research paper, the text, the tables, the figures, and learns all the statistical patterns and relationships. Then it generates a brand new, totally artificial data set that just behaves like the real one.
So here's the play-by-play. First, the system ingests and analyzes everything in the published paper. Step 2, it uses some really clever generative modeling to map out the statistical DNA of the research. You know, what are the variables? How do they relate to each other? What are the correlations? And finally, step 3, it generates a completely new, totally synthetic dataset that has the same structure and properties ready for anyone to use.
And this is the part you really got to get. This is so crucial. No private data is ever copied. No proprietary information is ever seen. It's not about recreating the exact same data points. It's about recreating the findings and the structure. And just like that, you sidestep all those privacy and legal roadblocks we talked about earlier. It's kind of brilliant.
The potential here is just massive, and it's not just a theoretical thing. Let's take a look at how this one framework can be applied across completely different fields, turning these static, dusty papers into living, breathing tools.
I mean, just look at the range here. It's incredible. You can use the exact same framework to create synthetic medical data based on research from a top hospital, and then pivot to model user behavior from a classic computer science paper from 1999. It can even generate datasets based on the economic ideas of Warren Buffett or the core logic from foundational papers in cryptography. The versatility is just mind-blowing.
And the best part is the output. It's not just some abstract theory. It produces a real, high-fidelity, machine-readable dataset. It's something a researcher can download and immediately plug into modern tools like Python or R and just start working, testing theories, and building on that original research.
So what happens now with such a powerful idea? Well, that brings us to where the project is today. It's not about selling something, it's about a systematic search for feedback and validation from the people who need it most.
This really shows you the potential shift in thinking. For decades, a scientific paper has been a static PDF. It's a report. The end. But the future could be this dynamic duo. You get the paper to read, and you get the synthetic data set to actually play with. It turns every scientific paper from a statement into a conversation.
And I want to be really clear about this. This is not a sales pitch. Dr. Cartoon was actually accepted into the National Science Foundation's super prestigious I-Corps program at MIT, And right now, he's just conducting structured interviews to get feedback from experts in the trenches.
What's the goal? Simple. Brief, 15-minute conversations with senior people in the industry. He's trying to validate the core hypothesis. If we gave you a synthetic data set along with a research paper, would that actually make science better? Would it solve a real problem for you?
Which leaves us with this one final, really powerful question to think about. We've got this trust problem, this reproducibility crisis, all because the real data is locked away. So could a digital twin of that data, one that's safe, open, and totally accessible, be the thing that finally solves one of the biggest challenges in science today?